Yeah, so those of you who have joined us, welcome. You got to hear a little bit of our banter about when we joined and where I'm currently living.
The Golden Girls.
Um, the Golden Girls. So welcome. Thank you to Pracarananda for being willing to be here today, take part in the conference, and for your presentation, which is entitled, what is the title of your presentation again?
It's on scientific literacy in devotional communities.
Thank you. And I will just introduce you, and then you can take it from there. Pracarananda Das joined ISKCON in Eugene, Oregon in 1997 and is a twice initiated disciple of His Holiness Krishna Kshetra Swami. As a brahmachari, he was a book distributor in the US, Germany, and Austria. He was also a full-time cook at Simachalam, Germany's ISKCON temple, dedicated to the worship of Sri Sri Prahlad Nrsimhadev. In 2005, Pracarananda went back to college, where he received a bachelor's and a master's degree in geosciences and science education from the University of Florida, where he was also on the board of directors at Gainesville's Krishna House. He then went on to earn a doctorate in natural sciences from the Freie Universität Berlin in the fields of geochemistry and hydrogeology. Following his education, Pracarananda became the director of geothermal energy research at the University of Alberta in Edmonton, Canada, a position he held for 8 years. In 2020, he retired from academic life to teach math, science, and physical education at the Bhaktivedanta Academy North America, New Raman Reti's parochial school. In his free time, Pracarananda likes to read, cook, and play music. He is also a dedicated practitioner of traditional Okinawan martial arts, a discipline in which he holds 2 black belts. Hare Krishna. Impressive.
Hare Krishna. I guess I was a little confused because we're the only people on the Zoom, but there are other people out there listening on other channels live. So
There are.
welcome to all of you. Good afternoon, and thank you for coming. I'm going to stop sharing the intro slide here for a moment and pull up some more slides here, which is my talk. And let me just see if this works. Okay, good. Yeah, so let me just say, first of all, that the intention here is that I'm going to talk for maybe 20 minutes to a half an hour, and then we have time for an open discussion if there's a way people can get their questions submitted. But the topic of this talk is on scientific literacy in devotional communities. And this is part of a broader project that I've been working on with the Bhaktivedanta Institute called Leaps of Faith and Doubt. And so here's the title slide of this talk, Leaps and Faith and Doubt, which addresses this topic of scientific literacy in devotional communities. And this gets back to my own involvement as a scientist. Katie mentioned in the introductions that I started studying science in earnest at the University of Florida, where I was both a student and a teacher of geological sciences. And as a teacher of geological sciences, I would always demonstrate the nature of scientific, excuse me, the nature of scientific evidence to incoming science students with the following cartoon here. And so this would be like in a lecture hall with like 300 people in it, teaching the introduction to geology. And I would put this picture up and ask the students just to describe what's going on. And if we've learned anything about science already, then we know that the scientific method usually begins with observation. And so we asked the students to observe what's going on here. And this is an observation that's predominantly made with the eyes, right? I'm looking at the picture. And of course, we know that we have other senses with which we can acquire knowledge of the material world with: the eyes, the ears, the nose, the mouth, the skin, and so forth. But people would look at this picture, and usually they would describe something having to do with a black cat crossing a street. You can see a black cat here crossing the street. And maybe I can get the pointer up. 1 second. Yeah, the laser pointer. Here we go. Here's a laser pointer. There's a black cat crossing a street. They might, infer something about the season based on the color of the years. They might infer something about the kind of road that we're on based on the lack of stripes or the overgrown grass, something about the time of day, excuse me, based on the length of the shadows here. But overall, we would get the impression of that there's a cat crossing the street. And then I would show them the next slide, and I would ask them this one question. And the one question is, what happened? So here we go. We're all going to get a look at this slide. And I want you to consider what happened. And because this is not an interactive essay, or an interactive lecture, I will just summarize what people usually say. So I'm going to show you another slide. And the question is, what happened? Boom. And so normally the response that we get at this point is that there's a car that ran over the cat that was previously crossing the street, right? Here's the cat now, and suddenly there's a car in the picture. And so everybody will say the cat got run over by a car. But in fact, nobody saw the cat got run over by the car. Everybody's making an inference, right? And so they're taking a leap of something. There's observational evidence here, and then there's how we interpret that evidence. And in that gap, there's a leap of faith or a leap of doubt. And again, this is the title of the talk, and I'll circle back to this in a moment. But what is some of the evidence that it's not an unreasonable conclusion? There was no car in the first picture. Now there is a car. Based on the nature of the drawing, there's some like speeding away marks in the car. It appears as though the car is in motion. It's a little blurry. And the cat is now kind of smushed against the road, if I can use sort of a gruesome example. And so it's not that there's no evidence to suggest this. It's just that we didn't see the whole thing transpire. And this brings us to the concept of leaps of faith and doubt, and a concept I like to call the asymptotes of knowledge. Asymptote is a word that you might not be familiar with unless you've studied math or science. But an asymptotes are shown here. These are graphs of a mathematical function, y equals 1 over x. And you can see that these red lines here, the graph of the function, approaches these axes here, but it never actually touches them. So this red line will go on forever and ever and ever in both directions, both against the y-axis, which is the vertical axis here that I'm highlighting, and against the x-axis here, which is the horizontal axis that I'm highlighting. The red line will get closer and closer and closer to the black line infinitely without ever touching it. And that's the nature of knowledge in the material world. We can perceive things in the material world, but our understanding of what our perceptions mean and even our interpretations of what we're perceiving are limited by certain restrictions on our consciousness. So what we're able to perceive here is analogous to the red line. And with our bare naked senses, we're only able to perceive a little bit of the material world. What we're able to perceive with our eyes is only actually a very limited spectrum of the entire electromagnetic radiation spectrum. What we're able to hear with our ears is limited to within a certain acoustic range. And so that's like down in here. And with our senses alone, we're not able to perceive much of the truth of the universe at all, right? We're really only aware of what's directly in front of us. And even regarding what's directly in front of us, there are so many misunderstandings and misconceptions. We do have the ability to expand the range of our senses using technology, excuse me. And that is akin to going further and further out on the red line here. And so with technology, we're able to see things that are smaller and smaller and smaller and smaller. Up until very recently, the last 200 years of human civilization or so, we were not aware of, for example, microscopic organisms. And so this has to do with the truth of the infinitely small. And then using microscope technology, we've been able to perceive the existence of things like atoms and electrons and subatomic particles and so on and so forth that we can't see in this range just with our sense perception. And the same is true with things that are infinitely large. When I was in middle school, which is what I teach here at the Bhaktivedanta Academy now, That was the time when scientists first found the first exoplanets. So even 30 years ago, we didn't know that there were any planets outside of our own solar system. Now, using technology that allows us to peer into the infinitely large, the universe, we're able to perceive that actually there are thousands upon thousands of exoplanets. They're fairly common in the universe. So the point here is that by using technology, we're able to expand the range of our senses, and we're able to perceive reality more directly. But in all cases, we will never be able to perceive all of reality as it is. There's always a gap between what we're able to perceive and what is truth. And that's just the nature of knowledge in the material world. I'm going to continue on to the next slide here. This raises the question of the philosophy of epistemology. Epistemology is the study of knowledge, and it's often used with a colloquialism. How do we know what we think we know? How do you know what your name is, for example? Somebody told you and you believe them, and it's written on a piece of paper, your birth certificate. So we know things in certain ways. According to the philosophy of the Vedanta and the philosophy of the Vedas, there are three different types of evidence that we can use to gather knowledge. And I've listed them here. This may be review for many of them. And I do want to review it briefly before I get into a little bit more of the meat of this topic. We can know things by direct perception. We can see them, we can touch them, we can measure them. We have direct experience of them. And this is also a bona fide yogic type of evidence. I'll come back to that in a moment. We know things through anuman, which is inference, logic, reason, and argument. Nobody saw the cat get hit by the car in the first example that I gave you, but there's enough other evidence for us to reasonably conclude that using logic, reason, and argument. And we do this all the time in our lives. And there are rules also for logic, reason, and argument. There are mathematical rules that govern how to establish whether or not a statement is true. And these mathematical rules are often applied to other areas of daily life. So they're used a lot in law, how to construct an argument. They're used a lot in business negotiations. How do you know when somebody has a position of leverage, and so on and so forth. And so anuman, logic, reason, and argument. This is one way that we know things, and this is one way that we agree upon a shared reality and what is the structure of a shared reality. And then finally, and this is the one that we are often most familiar with in a devotional context or in a religious context, is shabda. Shabda is hearing from a bona fide source. So I admit that I don't know anything, but I've identified somebody that does know something, and I'm just going to take their word for it. And when we talk about scientific knowledge, which is what this presentation is largely about, we're actually talking about all three of these things. When people first begin to study science, they're largely just taking some authority's word for it. As they become, I'm telling you what the truth of the matter is, and I'm telling you what the evidence of the matter is, and you just kind of memorize it and are able to regurgitate it. And this is where people's scientific education usually begins, unfortunately. When people become a little more advanced with it, they start to be able to understand why the evidence supports the claim. So the claim is that the universe is expanding, for example. Now I'm using the example of the Big Bang Theory. The claim is that the universe is expanding. The evidence of this is that when I look at distant galaxies in the universe, the spectrum of light they should be emitting is all shifted to the red side of the spectrum. This is a phenomenon known as the Doppler effect. And so this is why the evidence supports the claim. And this is anuman. None of us have ever gone to a telescope and seen this ourselves, right? But then there's also pratyaksha in science. When people become even more advanced, they start to learn how to do their own experiments. They start to learn how to do experiments that can make the evidence support the claim, so the experiments are well constructed and well performed. And in this way, the body of scientific knowledge develops. But science is not only a body of knowledge. So people often think that, well, the scientists say this and the scientist says that. And what they're doing when they talk about science in that light is that they're talking about science as the content or the body of knowledge that has been accumulated by scientists, what are now called scientists, over the last few centuries of human history. And that knowledge, that content knowledge is defined by some key, whoops, I went too far ahead. That knowledge is defined by some key criteria. The first is that scientific knowledge, by definition, is quantifiable. That means you can assign numbers to it and you can measure it. So in science, we don't just say things are big or small. We say it's this big based on an agreed upon unit. It weighs this much. It takes up this much space. And so scientific knowledge describes the material world in quantifiable ways. And this is important because this makes scientific knowledge verifiable. It's not subject to my opinion. It's subject to an agreed upon set of metrics. I'm just going to run through this list of criterion pretty quickly. The next one is scientific knowledge is repeatable. If I perform an experiment and you perform the same experiment under the same conditions, you should get the same results, regardless of whether you're doing this in America or Russia or China or Vietnam or Australia or regardless. If we do the same experiment, we should get the same results. The third thing I want to mention here is that scientific knowledge is peer-reviewed, which means other qualified scientists can chime in on whether or not the experiment you've conducted, the observations that you've made, or the conclusions you've drawn from those observations and experiments are valid. And in this way, science also, to a certain extent, represents the democratization of knowledge. Here's the fourth one here. Scientific knowledge is tentative, which means it will change in time. A lot of times people, especially people looking at science from a devotional or religious perspective, find fault with the scientific method because they'll say something to the effect of, well, the scientist said this today, and then they're going to say something else in 6 months. That's a feature of scientific knowledge. That means that scientists update their understanding of the universe once better information becomes available. So it is by nature subject to change. It is not conclusive knowledge like Vedanta. Vedanta, so the word Veda in Sanskrit means knowledge, and Vedanta means conclusive knowledge. So scientific knowledge is not meant to be Vedanta in that sense. It's not meant to draw a conclusion. It's meant for open-ended exploration with the results subject to change. And because of that, scientific knowledge is also cumulative. It adds up over time. There wouldn't have been a Galileo, for example. I'm sorry, there wouldn't have been a Galileo without a Claudius Ptolemy, who's this guy right here in the middle. And there would not have been an Isaac Newton, who's this guy over here, without a Galileo. Unfortunately, I do not have a picture of Galileo in here. And then, of course, there wouldn't have been an Albert Einstein without an Isaac Newton. So scientific knowledge builds on itself over time. And in this way, the body of knowledge of science is actually ever expanding. So these are some features of scientific knowledge. And where does this knowledge come from? There's a method behind it. And this is the more important part about science in the context of devotional life, is that science is not only the body of knowledge that's developed, but it's the methodology with which the knowledge has been developed. And I have here, just doing a quick time check. Yeah, I have here bullet points of the steps of the scientific process. In reality, this is not a linear process, but it does begin with observing the world around us using the faculty of our knowledge acquiring senses. And the function of the knowledge acquiring senses, the construction of the knowledge acquiring senses, and the interaction of the knowledge acquiring senses with consciousness is something that is explained in depth in the Bhakti Shastras, in the Srimad Bhagavatam, in various places throughout the Srimad Bhagavatam. So I won't get into great detail about this. This is the domain of Sankhya philosophy. But science also begins with observing the natural world around us and gathering quantitative data about it as far as possible. That data is organized into meaningful structures and systems. It's sorted. The noise is canceled out. It's taxonified, I think I want to say, yeah, which means it's put into relevant categories. And we also see this throughout the Bhagavatam and throughout Bhakti Shastras, is that the structures and the hierarchies of the material world are often divided into clearly elucidated categories. And so we see that there's already a lot of the scientific method within the devotional methods of bhakti. This data organization leads to hypothesizing. We look at the data and we can assert a claim about how a phenomenon is occurring, why a phenomenon is occurring based on the data. And we can test that claim through experimental methods and design. We get results, we share those results with the scientific community, we revise them, we analyze the nature of the conclusions, and as a scientific sangha, we can say we move the whole discussion forward. And what is the goal of all of this? Of course, the goal of all of this is to understand the nature of the material world. Communicate the results, start over, rinse, repeat, and so on and so forth. This is a little bit of a break here. I've introduced the concept of knowledge. How do we know what we think we know? I've discussed a little bit about the nature of scientific knowledge and how scientific knowledge is gathered. And I think with the next few slides and the next 10 to 15 minutes of this talk, I think I want to go on a little bit of a journey. If I have my slides correct. Yes. I want to go on we're going to take a little trip. It's a long weekend here in the United States. So long weekend to one of my favorite areas of the United States, the Colorado Plateau, which is roughly circled here. It's not quite this big, the Colorado Plateau. I made the circle a little bit bigger so the border could be thicker. But the Colorado Plateau is an area in the four corners of the United States. The four corners are where Colorado, Utah, New Mexico, and Arizona come together in, a rectilinear intersection like this. And the Colorado Plateau is a gigantic crustal block that has been somewhat recently uplifted by tectonic forces in such a way that pre-existing rivers, and most notably the Colorado River, has cut through flat-lying strata of earth, revealing what lies in the subsurface and the surrounding area. And so this allows us to observe into the earth in ways that we otherwise wouldn't. And one of the best places to do this is in the Grand Canyon. So this is a picture of the Grand Canyon here. And if you haven't been to the Grand Canyon, I definitely recommend it. It lives up to its name, let's say. It is grand. And so this is looking out over the Grand Canyon, and you can see where water has eaten into all of these otherwise flat-lying geological layers. You can see some layers up close and personal here. Excuse me. Some layers up close and personal here, and you can also see how they change off here in the distance. And you can also see here that there's a marked difference between the stuff on the top, which is like really broad, wide open canyons, and some, flatter layers here. You can see some flat here, some flat here, and then this kind of inner part, which is much narrower and much more like cliff-like. And so these are basic observations that you can make just from standing at the rim of the Grand Canyon. And here's what it looks like up close. And the reason why I'm bringing this up is because two different sets of observers look at this same exact canyon and come to very different conclusions about what this all means. So scientists will look at this. Well, let me do the other group first. And I don't mean to malign anybody's religious beliefs or religious traditions by doing this, but I do just want to point out that there is a class of Christians, mostly called young Earth creationists, who believe that the Earth is only 6,000 years old. And they will look at the Grand Canyon and point to the Grand Canyon as evidence of this, as direct scientific evidence that the Earth is only 6,000 years old. And that they say that this stuff down here on the bottom, this is the original ground of the Earth that was made during the Genesis creation story, which is a claim that they make. And then they say that all this stuff on top of it was deposited during Noah's flood, that during the great flood of Noah, there was all this debris and sediment being tossed around in the ocean. And when the waters dried up, all of this stuff was deposited on top of the original underlying basement, which is down here, which is also a claim. These claims are scientific claims in that they can be tested. They are falsifiable claims, which means that we have, using the scientific method, we have the ability to tell how old rocks are. This is a science called radiometric dating, which has been practiced in human society for over 125 years with astounding degree of accuracy. So two different groups of people can look at these rocks and come to two very different conclusions. And in this particular case, one of them is right. Not necessarily because they've proven themselves to be right, but they've been able to conclusively prove the other ones to be wrong. And so this is another feature of scientific knowledge, is that scientific knowledge has to be falsifiable. If I'm going to make a scientific claim, somebody has to be able to show that that claim is wrong. And so if I say that this sediment up here is only a few thousand years old, well, we have many different ways of showing conclusively that that stuff is more than 4,000 years old. So it's not that everybody's perspective is treated, or everybody's opinion or everybody's perspective or everybody's observations are treated equally or have equal value. Sometimes we get things right, other times we get things wrong. But back to the Colorado Plateau here. Oh, I'm sorry. Let me go back to this other slide. Now, how do the scientists explain this big gap here? They say something very different. Using the principles of radiometric dating, they date the ages of these rocks to be from the Mesozoic, which is when the time the dinosaurs lived, all the way down to the Paleozoic, which is before the dinosaurs lived. And this stuff here on the bottom where it says 3A, this is a geological unit called the Tapete Sandstone, and they say that this Tapete Sandstone is about 500 million years old. And they do this by dating the ages of the mineral grains in the rocks using radiometric methods. And then there's this squiggly line here, and they say that the stuff underneath this is way older than that. They say that the stuff underneath this is at least a billion years, a billion with a B, years older than this stuff. And in many cases, it's even much older than that. It could be 3 billion years or 2.5 billion years older. So there's an enormous gap of missing time here. And I'm pointing this out for two reasons. I'm using this example of the Grand Canyon for two reasons. Number one, from the perspective of the young Earth creationists, they look at this and using the power of their senses and their interpretation, they actually get it completely wrong. There's no scientifically justifiable way to explain this happened in 6,000 years. On the other side, the scientists who might know the ages of the rocks, they also revealed to the world to really not know much of anything. So they know how old these rocks are, and they know how old these rocks are, but there's this enormous gap of missing time in between them, where there's no geologic record of what may or may not have happened. And in the next few slides, I just want to point out the consequences of that and use this as an example to present a different idea of what knowledge is, because this gets kind of confusing. So let me continue here. Back to the Colorado Plateau and this missing span of time. This missing span of time that we see exposed in the Grand Canyon because of the local conditions is actually, here it is right here. The Tapete Sandstone up here is 550 million years old. And yes, this stuff is really called the Vishnu schist. These black rocks down here are named after Vishnu. I don't know why, but they are. They're at least 1.2 billion years older. And this span of missing time that is found in this red line, this gap right here, this is found in an area all over the Western United States that is marked out by this green circle here. This is a well-known geological feature called the Great Unconformity, and it covers this large of an area. Now, let me put this large of an area and this span of time in the context of human history. By comparing it to, we're going to do a little bit of a thought experiment with the Roman Empire. The Roman Empire was not the largest, but one of the largest and long-lasting empires that have ruled human history. So the Great Unconformity, this piece of geologic phenomenon I'm presenting here, spans at least 1.1 billion years. And it covers a geological extent of about 10 million square kilometers. That's about 3.85 million square miles for those of us in America. So this is an enormous geologic extent. Comparing that with the Roman Empire existed for roughly 2,000 years. So we're comparing thousands of years to billions of years. And it was a little more than half the size of this great unconformity. So if you do a little math and you put all those two things together, you could see quite easily that 1 million Roman empires could have risen and fallen within the span contained within this geologic feature, and there would be exactly zero evidence of it. There would be no evidence of it whatsoever. And so we don't really know much about the history of the Earth at all. 99% of all of the rocks that have ever formed on this Earth have been destroyed, which means any record of advanced civilizations, alternative life forms, anything that we read about in the Bhagavatam that we don't see in the fossil record, there's ample missing stuff for those to still be plausible claims. And this is different than the plausible claim of the Christian, or the young earth Christian, I should say. Not all Christians believe this. In fact, most don't, but there is a subclass. They make a claim that is falsifiable and has been falsified. The Bhagavatam makes claims that are actually not falsifiable because there's no way of telling if there were advanced human civilizations in the great distant geologic past, because whatever evidence there may have been of them have been destroyed by geologic process. Which brings us to another idea of what scientific knowledge is and why we talk about scientific knowledge so much in the context of devotional life. And I just want to read these in conclusion here. I just want to read these verses from the Bhagavad Gita too. This is Bhagavad Gita 13:8-12, which says, humility, pridelessness, nonviolence, tolerance, simplicity, approaching a bona fide spiritual master, cleanliness, steadiness, self-control, renunciation of the objects of sense gratification, absence of false ego, the perception of the evil of birth, death, old age, and disease, detachment, freedom from entanglement with children, wife, home, and the rest, even-mindedness amid pleasant and unpleasant events, constant and unalloyed devotion to me, Krishna, aspiring to live in a solitary place, detachment from the general mass of people, accepting the importance of self-realization, and the philosophical search for the absolute truth. All these I declare to be knowledge, and whatever else there is ignorance. And so this is what Krishna says knowledge is in the Bhagavad Gita. And I think it's important to note that here Krishna does not talk about anything having to do with content, a body of knowledge, or facts. All of these have to do with the qualities of character. And Krishna is saying here in the Bhagavad Gita that the sign of real knowledge is somebody who has developed these qualities in their character, and not somebody who knows about facts about the world and whatnot. And so this is a little bit of a different model of knowledge. And I just want to conclude by saying that these qualities of character are developed through the bhakti process, but the bhakti process itself, I'm going to go back right now. The bhakti process itself adheres to the principles of the scientific method. So we, by observation, have come to the conclusion that we are not our bodies, right? We've had enough experiences in our life to conclude that there's more to this reality than meets the eye. Otherwise, we would not be searching for spiritual meaning in our lives. And we assert this hypothesis. We assert the hypothesis that we are not this body, we are spiritual souls. And as a spiritual soul, I am a spark of a divine soul. And I'm related to that divine soul through the agency of service, or through the action of service. And this is an experiment. That's where the experiment of Bhakti Yoga begins. And this experiment is laid out by Srila Rupa Goswami in the eight steps of devotional life, starting with Shraddha, starting with a little bit of faith in the devotional process, and then going through Sadhu Sangha, Bhajana Kriya, Anartha Nivritti, and so on and so forth. And so this is the performance of the experiment, and these also then become the results of the experiment. And by performing these experiments in the association of devotees, we can come to realized, conclusive scientific knowledge about the truth of the soul in the material world. So that's all I've got for you today. I realize that was a little all over the place, maybe. But I don't know what to do now. Apparently, there are other people out there listening. I thought there would be some faculty for taking questions.
Thank you, Prabhu.
Yeah.
I don't see any questions in Facebook or in the chat. So is there anything else that you'd like to share? I think we have a little bit more time allotted for this presentation.
Yeah, there are some other things I would like to say just about the, let me see if I have any questions here or anything.
That was really
Yeah,
interesting.
one
by
last
the way.
thing
Thank
I'd
you.
just like to say about science within the devotional community, which is the broader topic of this discussion, is that Srila Prabhupada, our founder Acharya in the International Society for Krishna Consciousness, spoke often and somewhat aggressively about and against scientists. This is a fact, and you can go through his readings and see this itself. It started off with Easy Journeys to Other Planets, which was the first kind of full format book that Srila Prabhupada wrote, which he dedicated to the scientists of the world. And we also saw in his preaching, especially more towards the end of his life and more as ISKCON started to grow more and more, he started to focus his preaching more onto the scientist class of men, as he would call them. And I think there's a number of misunderstandings in the way that this type of preaching has been taken on by the devotional community after Prabhupada left his worldly form behind. Prabhupada did not disagree with the scientific method at all. And in fact, he said right in the introduction to the Srimad Bhagavatam that the world has made great advances in the realms of science and technology. So he acknowledged the benefits that science has brought society. And he also recognized scientists as the brahmanas of our time. So scientific knowledge is the standard of knowledge in our world. And so if we're trying to add to that, or if we're trying to redirect the misgivings of a wayward society, these are the people we need to address. The reason why I feel that scientific literacy is important in the devotional community, and the reason why I took some time to detail what is the nature of scientific knowledge, is that devotees often repeat talking points about scientific theories that just aren't true. The standard one is that, devotees often say that, evolution is wrong and humans couldn't have possibly evolved from monkeys. But evolution theory does not say that humans evolved from monkeys. So we wind up with this situation where we somewhat aggressively preach against scientists, but we don't really have a firm understanding of what scientific knowledge says about a given topic. And so for spreading the message of Lord Chaitanya, it is important to know what we're up against accurately and with integrity. And so I think it is important for us to keep ourselves informed about what the scientific community is saying, and not so much seek to be adversarial, but to seek where there's synergy, and also areas where there are known gaps in the scientific knowledge that perhaps the philosophy of the Bhagavat could inform the scientific community with, such as consciousness and so on. So I guess that's the last point I'd like to make.
Thank you for that. Yeah, that really tied in your content with the kind of broader context of this conference. So
Great.
Wonderful. Yeah, that opens up, I think, the arena for a lot of follow-up discussion on many different scientific topics and issues that there's probably been maybe misunderstanding or just not a lot of knowledge. Like the evolution topic that you brought up, there's probably a lot more that could be discussed. Are there any
Oh, for sure there is.
forums?
And let me just use this opportunity for a shameless plug also for all of you out there listening. The Bhaktivedanta Institute, based here there are many Bhaktivedanta Institutes around the world. I am associated with a Bhaktivedanta Institute in Gainesville, Florida, and we are actually putting on a conference about this topic of evolution in devotional life in January. And one other thing I'd like to add just about science. We try to embrace a plurality of vision. So Prabhupada also encouraged us as devotees to look at things from all angles of vision. So we should not be, as devotees, we should not be afraid with opinions or perspectives or facts that might contradict our beliefs. I mentioned this, the asymptotes of knowledge in the beginning of the talk. And really the difference between a devotee, a religious person, and a scientist is that between that gap of what we were able to say that we know and what we know that we don't know, a religious person or a spiritual person often takes a leap of faith. They will believe revealed knowledge with no evidence. And that's the definition of faith. And that's a choice that people make. That's a choice that people make. The scientist remains on the other side of that line. They remain skeptical, which is also a feature of scientific knowledge. Scientists are always skeptical. They're by definitions not believers. So because there's no evidence, I don't believe it. I'm taking a leap of doubt. And so when is it appropriate to take a leap of doubt in our devotional life? When is it appropriate to take a leap of faith? These are questions that we need to decide for ourselves as devotees. And there's no right answer to these things. There's also a plurality of vision. So I do think it is important for us to discuss these topics in an open-minded and vulnerable sense, vulnerable in the sense that I'm not afraid to have my beliefs challenged. It is a sign of weak faith that I cannot handle, people pointing out where the flaws in my arguments may be.
Mhm.
Yeah.
I appreciate that. And thank you for the shameless plug, because I was actually
Yes.
going to ask you if you had any recommendations for, other forums where people could tune in to become more educated or just, hear more about some of the scientific topics that would be valuable
That's a
for
great
us.
question, to be honest with you. And in teaching, I teach middle school and high school here, and so we do go to great lengths to try to get people to use like authorized sources when researching things. If people are interested in scientific topics, like you just want to know, like, what does science say about this? I actually highly recommend Wikipedia. Wikipedia has got a lot of great information about science. And it also has a lot of great images. And so I learn about science often visually. I look at visual models of scientific phenomena more than I read the words. And so I think Wikipedia has a lot of great information about evolution, the Big Bang, consciousness, the state of the art or the state of the history in these topics. And then if you want to go down into more, into the details of where Wikipedia is getting that knowledge, if you scroll to the bottom of the Wikipedia page, there are all the references that the Wikipedia article uses. Within the devotional community, there's VAST, which is an online forum of academic scholars, practicing Vaishnava academic scholars. I will say that Vaishnav Sangha in general has done a lot more work in becoming academically qualified within the humanities, theology, philosophy, history, religious studies, stuff like that. And we have many prominent scholars in our movement placed in academic institutions in these lines. We've done a comparatively weaker job encouraging devotees to become educated scientists, so like me, getting higher education within science, STEM fields, science, technology, engineering, and mathematics. So for the young people out there, for the parents with children out there who may be listening, STEM fields are a great way for your children to have a guaranteed job when they graduate. But it's also a method of critical thinking. And this is what I tell a lot of my students here at the Bhaktivedanta Academy when they start complaining about math and science, especially math, like, when am I ever going to need to know this? Algebra, who cares what X equals? But solving for X in these algebraic equations is not really about solving for X. It's about knowing how to get the right answer. Like, there is a right and wrong in this world. Although truth is ultimately in the material world relative, there is still an objective reality here. There is still truth in this world. 2 + 2 does equal 4. And there's a whole, that's quantifiable science. And there's a whole genre of philosophy that falls out of that simple fact. And everybody who's dealt with teenagers knows that teenagers love to be right and they love to argue. And so knowing how to solve for X is actually knowing how to be right and knowing how to win an argument. And everybody can buy into that, right? Everybody wants that. So science is about critical thinking beyond the factual content of science. And if there's one overriding take-home method I'd like to message I'd like to give the devotional community here is that science is not only facts, right? In fact, that's a relatively small part of what science is. And those facts are subject to revision over time. The real point is the method of critical thinking. And we should bring that method of critical thinking wholeheartedly to our devotional lives as well. That's what Prabhupada meant by the science of self-realization, critical analysis of the nature of the soul.
Yeah, thank you for that. And thank you for the recommendations on forums where we can, go to just kind of get more plugged in on what's happening with science in the Vaishnava world and just the, greater context of society. I do have one question. I'm personally curious what might some of the other scientific issues be that have maybe created the most difficulty for the Vaishnava community in trying to understand or like integrate with Vedanta. Are there any other ones that you'd want to mention?
Yeah, the two big ones are clearly the so-called Big Bang theory, which is a colloquialism that was coined by a Catholic priest. He didn't coin the theory. Somebody used that term. A Catholic priest, George Lemaitre, came up with this idea. So he was a priest. He worked for the church in a Catholic institution doing science. And he came to this conclusion that the universe is expanding and therefore probably began with an explosion. And some guy ridiculing him said, it's not like there was a Big Bang. So this is what the theory is called. And in my opinion, and I've spoken about this extensively, both here in Alachua, as well as in writing and as well as in other online forums, that actually the Bhagavatam describes the Big Bang theory in great detail. There's very little difference between what we observe as the Big Bang and what the Bhagavatam describes as the creation of the universe.
Right.
And so I think a lot of devotees are just not well educated about what the evidence of the Big Bang theory is. And then they use their own lack of knowledge to kind of claim that the scientists don't know what they're talking about. The scientists do very much know what they're talking about, but it's also subject to change. It's also subject to everything else I said about the scientific method. The other one is evolution. Again, it's a situation where I think a lot of I don't think this is too provocative to say. I think what has basically happened is that Prabhupada would love to argue with his disciples on morning walks, and he would bring up topics for discussions to show his disciples how to debate different philosophical topics of the time. And a lot of times when the devotees were engaging in this, back and forth with Srila Prabhupada, they were just saying things to Srila Prabhupada that they didn't know, right? They were just saying things that they didn't know about. And so what got recorded in the historical transcripts is Prabhupada giving comments on information that was just not that accurate. And then in the absence of the great Acharya, people try to imitate, right? And so they took Prabhupada's kind of pugilistic, playful attitude to go on full frontal assaults again. And now I'm in the ISKCON in the 80s, 80s, early 90s like this, where it was just like aggressive full frontal assaults on scientists. And I think that I've seen this personally with my own eyes, doing book distribution on the streets and being educated in science myself, that this is just an immediate way to turn off any educated person from thinking that we're a serious religious movement. It's just bad preaching. And we don't need to preach along those lines. Krishna is all attractive. Any way you look at Krishna, he is attractive. And so we don't need to attract people to Krishna by pointing out the flaws in somebody else's existence. That's appropriate preaching in a certain time, place, and circumstance, but it is not an overriding preaching strategy. I think the mood started to change a little bit with some of the more mature writings of Sataputra Prabhu and others who started to maybe try to see a little bit more nuance in this topic. And our current iteration of the Bhaktivedanta Institute is working hard to have a more pluralistic and more synergistic relationship with the scientific community. And it's hard because scientists are also very dogmatic. Like they don't, the misinformation and the not necessarily discussing in good faith is really on both sides. It's not only, the scientists can also be quite dogmatic, as we know. But we want to be, Prabhupada said, Krishna consciousness is not an artificial imposition on the mind. We also don't want to be dogmatic about our own spiritual realizations. And so, when I hear people in the devotional community talk about, quote, like, what do we believe? I get a little, hold on, who is the we in this discussion? Because even as devotees, we have different viewpoints and different understandings of what the scriptures mean in our own spiritual lives. So this is an ongoing work. In conclusion, I'll say now, Prabhupada's instructions to the Bhaktivedanta Institute along these lines were actually fairly limited. So devotees in the intervening 47 years since Prabhupada left, and Prabhupada was giving instructions to members of the Bhaktivedanta Institute literally right up into his death. Right up until he died. So even in the last days of his life, he was interested in hearing reports from scientists in the devotional community. But his instructions to these scientists were really quite limited. And they very much focused on this idea of life comes from life. Life comes from life. And that is to say that consciousness does not arise from a mature combination of material elements. Consciousness itself is a fundamental ingredient in the material world. And what we perceive as life comes from that consciousness, not the other way around. And so this has to do with the scientific study of consciousness, which is cutting edge scientific study that we would encourage anybody to get involved with.
Thank you. Yeah. Wonderful. Well, I appreciate
I've exhausted the full hour now.
Yeah. I'm glad. That was amazing.
Yeah,
a lot of good food for thought, and I'm glad this presentation was a part of the conference this weekend. So thank you for joining it.
Yeah, thank you for having me. I hope there were some other people out there listening.
Yeah, me too.
Okay.
All right, everyone. Thank you.
Right.
And until next year's Progressive Vaishnavism Conference, we'll look forward to that.